about it this morning. I woke up with a terrible headache. Elevation, that's what was last night.
Okay, so elevation, but truly, you have to keep pushing the laws of physics. You have competitors who are nipping at your heels, both on the software and hardware side. You are somewhat reliant on the geopolitical stability of the South China Sea, geopolitics, so much going on right now.
You're reminding me, it's super hard building a company.
It is, but you've had a lot.
You're making me nervous. I was fine before. There's so many things that
he wants to go back to showing you slides. But truly, you've had a lot of tailwinds, and I'm just, how optimistic are you that these things are going to keep trending in your direction?
Things have never trended in our direction. You have to will the future into existence. Accelerated computing, the world wants general purpose computing, and the reason for that is because it's easy. You just have the software, it just runs twice as fast every single year, don't even think about it. And every 5 years is 10 times faster, every 10 years is 100 times faster. What's not to love? But of course you could shrink a transistor, but you can't shrink an atom. And eventually, the CPU architecture ran its course. And so it's not sensible anymore, as the technology doesn't give us those leaps, that a general purpose instrument could be good at everything. Could be good at these incredible things from deep learning to quantum simulation to molecular dynamics to fluid dynamics, right, so on, so to computer graphics. And so we created this accelerated computing architecture to do that. But that's headwind. Do you see what I'm saying? Because general purpose computing is the easy way to do it. We've been doing it for 60 years. Why not keep doing it? And so accelerated computing was only possible because we deliver such extraordinary speed-ups. At a time when energy is becoming more scarce, at a time when we no longer can just ride the CPU curve any longer, Dennard scaling has really ended, and so we need another approach, and that's why we're here. But notice every single time we want to open a new market, like QDF, in order to do data processing. Data processing is probably what, a third of the world's data, a third of the world's computing. Every company does data processing, and most companies' data is in data frames, in tabular format. And so in order to create an acceleration library for tabular formats was insanely hard, because what's inside those tables could be floating point numbers, 64-bit integers, it could be numbers and letters and all kinds of stuff, and so we have to figure out a way to go compute all that. And so you see that almost every single time we want to grow into something, you have to go and learn it. That's the reason why we're working on robotics. That's the reason why we're working on autonomous vehicles, to understand the algorithms that's necessary to open up that market and to understand the computing layer underneath it so that we can deliver extraordinary results. And so, as you can see, each time we open up a new market, healthcare, digital biology, the amazing work we're doing there with BioNemo and Parabricks for gene sequencing, every single time we open up a new market, it just requires us to reinvent everything of that computing. And so there's nothing easy about it.
Generative AI takes up a lot of energy.
I'm just saying, my job's super hard.
But your assistants, your AI assistants are going to make it easier, right?
What's that? Somebody's got to pat my back. Hey, a little applause, you guys. Cheer them on. Yeah, go ahead.
Let's talk about energy.
Yeah.
Generative AI, incredibly energy intensive. I am going to read from my note cards here. According to some research, ChatGPT, a single query, takes up nearly 10 times the electricity to process a single Google search. Data centers consume 1 to 2% of overall worldwide energy, but some say that it could be as much as 3 to 4%. Some say as much as 6% by the end of the decade. Data center workloads tripled between 2015 and 2019. That was only 2019. AI, generative AI, is taking up a large portion of all of that. Is there going to be enough energy to fulfill the demand of what you want to build and do?
Yeah, yes. And a couple of observations. So first, there are two or three or four model makers that are pushing the frontier a couple of years ago. There are probably 3 times that many this year, but it's still single digit. You know, it's a very high single digit, but call it 10, that are pushing the frontiers of models. And the size of the models are, I call it twice as large every year, maybe faster than that. And in order to train a model that's twice as large, you need more than twice as much data. And so the computational load is growing probably by call it a factor of 4 each year, just for simple thinking. Now that's one of the reasons why Blackwell is so highly anticipated, because we accelerated the application so much using the same amount of energy. And so this is an example of accelerating applications at constant energy, constant cost. You're making it cheaper and cheaper and cheaper. Now, the important thing though is I've only highlighted 10 companies. The world has tons of companies, and there are data centers everywhere. And Nvidia is selling GPUs to a whole lot of companies and a whole lot of different data centers. And so the question is, what's happening? At the core, the first thing that's actually happening is the end of CPU scaling and the beginning of accelerated computing. Data processing, just text completion, speech recognition, all of those kind of basic AI things that are used, recommender systems that are used in data centers all over the world. Everyone is moving from CPUs to accelerated computing because they want to save energy. Accelerated computing helps you save so much energy, 20 times, 50 times in doing the same processing. So the first thing that we have to do, as a society, is accelerate every application we can. If you're doing Spark data processing, run it with accelerated Spark so that you could reduce the amount of energy necessary by 20 times. If you're doing SQL processing, do SQL, accelerated SQL so that you could reduce the power by 20 times. And so if you're doing weather simulation, accelerate it. When you're doing whatever scientific simulation you're doing, accelerate it. Image processing, accelerate it. A lot of those applications used to be running on CPUs and general purpose computing. All of that should be accelerated going forward. That's the first thing that's happening. Now, is that reducing the amount of energy being used all over the world? Absolutely. The density of our GPUs and the density of accelerated computing is higher, energy density is higher, but the amount of energy used is dramatically lower. So that's the first thing that's happening. Of course, then generative AI. Generative AI is probably consuming, let's pick a very large number, probably 1% or so of the world's energy. But remember, even if the data centers consume 4% of the world, the goal of generative AI is not training. The goal of generative AI is inference. And the inference, ideally, we create new models for predicting weather, predicting new materials, allow us to optimize our supply chain, reduce the amount of energy consumed, the wasted gasoline as we deliver products. And so the goal is actually to reduce the energy consumed up to 96%. And so very importantly, you have to think about AI from a longitudinal perspective, not just going to school, but what happens after going to school. You and I both went to Stanford. Stanford's not inexpensive.
I think you studied something slightly different, though.
Yeah, sure. It's a big school.
It's worked out well for me.
It's worked out well for both of us. And so the goal, of course, is going to school is important, but of course the important thing is really after school and all of the contributions that we're able to make to society. And so generative AI is going to increase productivity. It's going to enable us to discover new science, make things more energy efficient. Don't let me finish without showing you the next. And so that
also,
accelerated computing.
The lights just came on because we were talking about energy, and all of a sudden it's like the Earth was like, okay, tamp down the energy usage.
I thought they were good. Am I getting?
I think we still have a few minutes, okay. So I mean, I hope so. I mean, I'm not going to get off the stage until Mark Zuckerberg comes on here and kicks me off. How about that?
He's not going to do that. He's a great guy. So anyways, think about generative AI longitudinally and all the impact of generative AI. The second thing, the next thing I'll say about generative AI is, remember, it's the traditional way of doing computing is called retrieval-based computing. Everything is pre-recorded. All the stories are written pre-recorded, all the images are pre-recorded, all the videos are pre-recorded. And so everything is stored off in a data center somewhere, pre-recorded. Generative AI reduces the amount of energy necessary to go run to a data center over the network, retrieve something, and bring it over the network. Don't forget, the data center is not the only place that consumes energy. The world's data center is only 40% of the total computing done. 60% of the energy is consumed on the internet, moving the electrons around, moving the bits and bytes around. And so generative AI is going to reduce the amount of energy on the internet, because instead of having to go retrieve the information, we can generate it right there on the spot, because we understand the context, we probably have some content already on the device, and we can generate the response so that you don't have to go retrieve it somewhere else.
Well, part of that is also moving atoms around, right?
And then
part of that is supply chain.
one last thing I've got to
Which, okay.
One last thing I've got to remember, AI doesn't care where it goes to school. Today's data centers are built near the power grid where society is, of course, because that's where we need it. In the future, you're going to see data centers being built in different parts of the world where there's excess energy. It's just that it costs a lot of money to bring that energy to society. Maybe it's in a desert, maybe it's in places that has a lot of sustainable energy, but it's
They're already
not a
taking
very
up a
attractive.
lot of water.
Well, there's plenty of water as well. It just happens to be undrinkable water, and so we can use water that are we can put data centers where there's less population and more energy. Okay, just don't forget that there's a lot of energy coming from the sun. There's a lot of energy in the world, and what we need to do is move data centers out closer to where there's excess energy and not put everything near population.
Well,
AI doesn't care where it's trained.
I never heard that phrase before. AI doesn't care where it goes to school. That's interesting.
Yeah, it's true.
I'm going to think on that.
Yeah.
Part of calculating carbon emissions, though, is also considering the supply chain. It's also considering it's going all down the line, and it requires transparency.
Don't move the energy to the data center. Use the energy where the data center is, and then when you're done, you have a highly compressed model that is essentially the compression of all the energy that was used, and we can take that model and bring it back. Hey, can we talk about the next wave? So the first wave, of course, is accelerated computing.
I think
I know that she's the interviewer, and we're doing this on her terms, but I'm the CEO, so. We need to come and tell this group about the work that we're doing that is really core to.
I have so many good questions for you.
I know.
I want to ask you about open source, which I think you're going to be talking to Mark about. I want to ask you about.
By the way, open source is really important. It's incredible. Yeah. And if not for open source, how would all of these industries and all these companies be able to engage AI? And so look at all the companies and all the different industries. They're all using Llama 2 today. Llama 3.1 just came out. People are so excited about it. We've made it possible to democratize AI and engage every single industry in AI. But the thing that I want to say is this. The first wave is accelerated computing reduces energy consumed, allows us to continue to sustain computational demand without all of the power continue to grow with it. So number one, accelerate everything. It made it possible for us to have generative AI. The generative AI, the first wave of it, of course, is all the pioneers. And we know many of the pioneers, OpenAI, Anthropic, Google, Microsoft, a whole bunch of amazing companies doing this. X is doing this, X.AI is doing this, amazing companies doing this. The next wave of AI we did talk about, which is enterprise. Of course, one of its applications is customer service, and we hope that we can give every single organization the ability to create their own AIs. And so everybody would be augmented and have a collaborative AI that could empower them, help them do better work. The next wave of AI after that is called physical AI. And this is really quite extraordinary. This is where we're going to need 3 computers. One computer to create the AI, another computer to simulate the AI, both using synthetic data generation, as well as a place where the AI robot, the humanoid robot or the manipulation robot, could go learn how to refine its AI. And then, of course, the third AI is the computer that actually runs the AI. So it's a three computer problem. You know, it's a three-body problem. And so it's incredibly complicated, and we created 3 computers to do that. And we made a video for you to enjoy understanding this. The thing that we've done here is this. In each one of these computers, depending on whether you want to use the software stack, the algorithms on top, or just the computing infrastructure, just the processor for the robot, or the functional safety operating system that runs on top of it, or the AI and computer vision models that run on top of that, or just the computer itself. Any layer of that stack is open for robotics developers. We created a quick video. Let's take a look at that. Is that okay?
That sounds great.
The era of physical AI is here. Physical AI, models that can understand and interact with the physical world, will embody robots. Many will be humanoid robots. Developing these advanced robots is complex, requiring vast amounts of data and workload orchestration across diverse computing infrastructures. Nvidia is working to simplify and accelerate developer workflows with 3 computing platforms: Nvidia AI, Omniverse, and Jetson Thor, plus generative AI-enabled developer tools. To accelerate Project Groot, a general humanoid robot foundation model, Nvidia researchers captured human demonstrations, seeing the robot's hands and spatial overlay over the physical world. They then used RoboCasa, a generative simulation framework integrated into Nvidia Isaac Lab to produce a massive number of environments and layouts. They increased their data size using MimicGen-NIM, which helps them generate large-scale synthetic motion datasets based on the small number of original captures. They trained the Groot model on Nvidia DGX Cloud with the combined real and synthetic datasets. Next, they performed software-in-the-loop testing in Isaac Sim in the cloud and hardware-in-the-loop validation on Jetson Thor before deploying the improved model to the real robots. Nvidia Osmo Robotics Cloud Compute Orchestration Service manages job assignment and scaling across distributed resources throughout the workflow. Together, these computing platforms are empowering developers worldwide to bring us into the age of physical AI-powered humanoid robots.
At this conference, SIGGRAPH, is where all of this technology comes together. Isn't that right, everybody? Researchers of SIGGRAPH, isn't that right? So whether it's computer graphics or simulation, artificial intelligence, robotics, all of it comes together right here at SIGGRAPH, and that's the reason why I think you should come to SIGGRAPH from now on.
Me?
Yes.
I'm happy to. I'm thrilled to. I took
everybody? 100% of the world's tech press should come to SIGGRAPH.
We can get behind that. Just drink a lot of water. I went and saw some of the art exhibits last night upstairs in the exhibition effort. Fantastic. Just really, really cool. Loved the literal spam bots, whoever created that one. Go check it out. I was actually listening to the SIGGRAPH Spotlight podcast before this. If folks haven't listened, I really recommend it. The Special Projects Chair was interviewing a couple of graphics legends, including David Yam. And one of the things that David Yam talked about was archives. And this is kind of an existential question for this crowd, right? But people are creating this really amazing digital media, all of these computer graphics. You are accelerating it with your technology. It changes so fast now. How do you ensure that everything folks are building lives into the future? File formats, archives, accessing all of this work in the future. The robots will live on.
Yeah.
I have no concern, they're going to take over, right? What about the art that people are creating? This is the existential question.
Well, that's an excellent question, and one of the formats that we deeply believe in is OpenUSD. OpenUSD is the first format that brings together multimodality from almost every single tool and allows it to interact, to be composed together, to go in and out of these virtual worlds. And so you could bring in just about any format, ideally, at a time into it. At this conference, we announced that URDF, the Universal Robotics Data Format, is now compatible with, or it can be ingested into OpenUSD. And so one format after another format, we're going to bring everything into this one common language. Using standards is one of the best ways to allow content and data to be shared, allow everybody to collaborate on it and to live forever. For example, HTML. Without HTML, it would have been hard for all of these different content from around the world to be accessible to everybody. And so in a lot of ways, OpenUSD is the HTML of virtual worlds. And we've been an early promoter of it. There's amazing companies that have joined and many other companies joining. And my expectation is every single design tool in the world will be able to connect to OpenUSD. And once you connect to that virtual world, you can collaborate with anybody with any other tool anywhere. And so
you said
HTML.
You said this content can live forever. Are you going to build a Jensen AI that lives forever?
Absolutely, there's a Jensen AI. In fact, just about everything that I've ever said, everything that I've ever written and ever done, will likely be ingested into one of these generative AI models. And I'm hoping that happens. And then in the future, you'll be able to prompt it, and hopefully something smart gets said.
So Jensen AI is going to be running your earnings calls in the future.
I hope so. That's the first thing that has to go. That's the first thing that has to go to a bot.
Jensen, thank you so much. I think we're probably going to get kicked off stage soon, but you'll be back shortly with Mark Zuckerberg.
Yes, and welcome to your first SIGGRAPH. Ladies and gentlemen.